Alright, so we're gonna do we're just going through simplifying really. Different ways to simplify. So if you look at these, they're all product and chain, but without the negative exponents. So you get the negative exponents, that's when you gotta flip things to the bottom, you get those two fractions, you gotta get the common denominator. And above, this stuff we did like crazy like Friday. So this is kind of chain product without the negative exponents. So I just wanted to go through a few of these. The rule here is you want one term. So, for example, in a non-calculus question, if you had like 3x to the third plus 6x squared plus 9x, that's 3 terms. But if I were to factor a common chunk out, I have actually only got 1 term. The advantage of that, or the reason for that, is now I could set this equal to 0 easily because I've got like my chunks. It's a multiplication problem now. So I could then set these pieces equal to 0 and solve it and get x values. Where up here it's a little tougher. So I mean it's not like a huge step, but that's the reason for it. That's why you're being asked to do that. So I'm doing number 1. I assume it's okay if I do some on your worksheet instead of like other ones. So, first of all, realize that's product rule, right? So I've got a chunk with an x in it and a chunk with an x in it. They're being multiplied. It's 2d1 and 1d2. When I take the d2, some of these have 2 chain rules, some only have 1. Like this doesn't have 2, this just has 1. So my derivative will be the second thing times the derivative of the first thing. So in this case, the derivative of the first thing does not require chain rule, right? What's the derivative of x to the 4th minus 2? 4x. It's just 4x to the 3rd. So that's 2d1 and then plus the first thing times the derivative of the second thing, and now that will require chain rule. So the derivative of natural log is 1 over whatever. And then, so that's like the derivative of the outside. Leave the inside alone. And then you multiply by the derivative of the inside. So the 2 rules that you have to worry about on this worksheet or in the gateway in general are you can't have 2 fractions. Basically you want 1 term. So whether it's 1 fraction or 1 term, it's not a fraction. That's your goal. So I can make this 2 over x. Yes? Like 8 over 4 is 2, and then the x over x squared will just leave me with an x on the bottom. So let me just rewrite that as a step. And I'm going to put that x on the bottom of the x to the 4th minus 2. No, that's not a 2, that's x. Times 2. Hey. We good there? So this is common denominator stuff from last week, but it's a little easier than it was last week. What do I need at the bottom? What do I need over here? I need an x on the bottom over here. So I need an x on the top up there, so I really just multiply by 1. And then I will have, so it's like 4x to the 4th times the natural log of 4x squared over x plus, let's say I distribute that, so 2x minus 4 over x. Did you guys see, like, did any of you asked about putting, like, our form of the answers on school? Did you have to put them on there? So I did go through and put, like, because the answers on the packet I gave you were pretty garbage. They were weird forms, simplified weird, but I put, like, how we would do it and put our answers on there.
Yeah, it's
I wasn't talking to you.
I'm the same. It's not.
Yeah. No, you'd be okay. And then I've got my common denominator, so I can just add up across now. So it's like 4x to the 4th times ln of 4x squared. And then, yeah, so you might have had just like 2 times x to the 4th minus 2 here, all over x, or you might have distributed this, like whichever. That's what you're saying, right? Question on that? Yeah. So, like, if you want to leave this here, go for it. Okay. Technically, that's just like adding, subtracting, multiplying, dividing, so you're good. Is that okay? Why don't you try 2? Is 2 like that one? Yeah, so try 2. It's like similar type, just different numbers. Listen to the phones in this row over here, guys. What? You said the right answer. Jack, was that helpful for you? like the answer in the back of this one a little better. So this is my second thing, and then the derivative of the first thing. So the derivative of natural log of 4x to the third is 1 over 4x to the third times the derivative of 4x to the third. And then my first thing times the derivative of the second thing. And then I would probably write this as 3 on top and x on the bottom. So it'd be like 3 times x squared plus 4 over x plus ln of 4x squared times 2x. You okay there? Questions? Stop. For a second, I thought you were going to do this. Good. Then you do that, which I think is
Wait, we should get the natural log of 4x squared.
goodness gracious. It's just because I can't.
Oh, okay.
It's just because I can't focus for more than like 2 seconds. Are you good then?
Yeah.
Again down here.
Yeah.
Okay, so then what do I need over here? I have an x on the bottom, right? So I'm going to add these up. So you can put times x here. I think it's just easy. Probably just put a squared, but either way. And then just add up going across. So 3 times x squared plus 4 plus ln of 4x to the third times 2x squared, and then that's all over x. Sound okay? And they might have factored like slightly different at the bottom. I'm not too worried about like factoring specifically the way they do. Like the ideal factoring as long as you factor. So let's look at, there's 2 more types. There's the kind with an E, and there's the kind with just a bunch of powers. So let's look at like number 3. Am I okay to move on from this, or are we still? Okay. So let's say number 3. So again, chain and products. There's only 1 chain rule, not 2. This part doesn't need chain rule, just this part does. So it's your second thing. So e to the 3x to the 5th times the derivative of the first thing, which is 8x to the 3rd. Right? Because the minus 1 just kind of drops away. Plus the first thing times the derivative of the second thing. So what's the derivative of e? Z. Leave the little guy alone. And then you multiply by the derivative of the little guy, which is 15x to the 4th. So what's going to happen in these is you're going to be able to, because there's going to be an e twice. If you have an e in it, you're going to leave the e once. And then the other one, you're going to multiply by the derivative. You're going to have the derivative of e. But what's the derivative of e? It's e. So you're going to have this same chunk in both terms. And you're going to want to factor that out. Typically in like reverse distributive property basically. Yeah. It would be, so you're thinking, I think, like this. But then that really would be like a power to a power. So it, and then you'd multiply, so that would probably be written like this, actually. So it kind of wouldn't be really. Doesn't mean you're dumb. Fine question. So you can like factor out more, and I would kind of encourage you to, but I'm not going to force you to. So like the 8 and 15, so I've got 1 term here and 1 term here. So the 8 and 15, nothing goes into both of those numbers. But couldn't I take an x to the 3rd out of both of these? So like the answer I'd really like to see, I'm not going to make you, would be take e to the 3x to the 5th, let me fix the term so I can kind of explain a little bit what's happening. Times x to the 3rd from each chunk. And what that means is you're dividing both chunks by e to the 3x to the 5th times x to the 3rd. It's like distributive property backwards. Well, distributive property is multiplication, right? So what's reverse distributive property? Division. So when I do this here, that's gone, so I really just have 8. plus. When I take it out from here, that's gone. 3 of those are gone. So I'll have 2x to the 4th minus 1 times 15, and then you're actually okay, because all that's left is adding, subtracting, multiplying, dividing. Yeah. Oh, yeah. 50x. Thank you. So this is not fine. This is fine. What some people might do is like forget about the x to the thirds. I'm not going to worry about it, and they would say this. And I would say like you could factor the x to the third out also. But you don't have to. So this is better. This is good enough. Yeah. Yeah, it's like in the parentheses makes me see it. Other questions on that? You can't leave it like this. So again, the advantage here is if I set this equal to 0, you've got a piece you can set equal to 0 and another piece you can set equal to 0. Where up here, I don't have that. But either of these two do have that. The only kind of choice you're making is do I want to take that x to the third out or not. You need to take the e part out. You always need to take the e part out. Is that right? Is number 4 one of these two? 5, so go to 5 then. So execute. Zero tolerance. Really hyper aggressive. But you can tell. That's part of like, that's worth practicing. Alright, so second thing times the derivative of the first thing, so 6x squared plus first thing times the derivative of the second thing, which is e to the x to the 5th, and then times the derivative of x to the 5th, which is 5x to the 4th. So let me do this in parts. If I just take an e to the x to the 5th out, what's left here is 6x squared. What's left here would be 2x to the 3rd plus 3 times 5x to the 4th. And you can kind of check if you were to distribute this back, wouldn't you end up with that stuff we just had before? That's the idea. We're kind of packing it, I guess. Unpacking it. So you can stop there. You could also be a little more thorough about it, and I could take the 6 and the 5 doesn't work, but the x squared, I could take an x squared out of both of those. And then this would be 6. And this would just be 5x squared now. if I multiply that x squared in, that'd give me the 6x squared, and the 5x to the 4th. So, either of these are fine. I think on the AP test you would be more likely to see this. And on a multiple choice, they might even like add up this stuff in the middle. But it's not like that's hard to do, right? You need to. But on the gateway, I'll take either one. Those are good?
How come the EX, e to the x to the 5th, just, why is it not in the brackets?
Why is it out here, you're saying?
Why is, no, I understand why it's out there, but why is the other one not in the brackets?
This one?
Yeah.
So, like, when you distribute, you know, like 3 times x plus 6, 3x plus 18, right? Well, if you reverse distribute, you're really dividing. So, like, what's 3x divided by 3 is x. 18 divided by 3 is 6. So I'm dividing this entire thing by e to the x to the 5th, which makes it cancel. And it's out here instead. But I'm also dividing this entire thing by e to the x to the 5th, which makes it cancel. You know what I'm saying?
Yeah.
And then if you were to like distribute, it would come back because you'd end up multiplying by this, plus you'd multiply by that. So it would end up in both spots. Those are good? Yeah. This 3? Think about it like, this is like A plus, well, that's not the greatest way. You're not doing anything to the 3 though. I can prove it to you if I distributed it out. Because this 5x to the 4th will eventually be distributed to both of those, right? So the x squared is technically coming from both, even without having to do it to both. You with me?
Yeah, so you figured out the 5.
Yeah, yeah.
Well, yeah, but anything in like parentheses is considered like 1 2.
Oops. Right, exactly. That's what yeah, so you're taking it from that term. Yeah. Other questions on that? Yeah.
So the answers in the back,
Yeah.
are they distributing like everything?
I think they're like,
Added, like the whole bracket kind?
I think they factor like everything they possibly can. So you would just, and you don't have to do that, but it's good practice to see if what you're doing is the same as what they're doing, because that's how the AP test works, right? Multiple choice is trying to like match up what they did. So like in number 5, for this one here, you don't have to take that x squared out. Yeah. So you gotta do a little bit of adjusting here there. I'm okay with that. Are we okay in those two, like the ln and the e types? So then jump to number, let's say 11. So part of it is like, you know, the AP test, and I guess being friendly about like, you don't have to simplify, but sometimes to check your answer, you're going to have to simplify. You know, so you could look at it as you're being penalized, but I would say you're just like being asked to do what's normal. 11. So I've actually got to take this. Sorry. Okay.
No. I feel like I'm gonna do like on the first one. That's what counts as scooters. I actually understood. I don't know how to do that. Where? Oh, on the back?
Oh, no, because you have like this stuff right now.
Yeah.
My test.
Oh, okay.
Oh,
Okay.
No, it was like when we started.
Doing
Yeah.
That's what I thought, but I don't know. It's like
Yeah, I literally just
Okay, I actually.
I don't can.
Why?
Zach, you gotta play building.
It's so weird. It's like this, like
They're all
separate towers.
Well, yeah, but like so.
And I don't know how to use it right now. Like, wait for it to do this. I'm sitting here like,
Oh, exactly. We should have figured it out. Oh, okay. Wait. Wait. Negative.
you run drag too. Awesome cars.
Where did I go from here? Stop it, I go. I feel like we need to factor something out.
Oh yeah.
Wait, but they're all correct. Jack, wait. What? He's like, just killed Bambi. He's like, well, if he gets hit. She was like, she was that first part, right? Hopefully, try to get some perks. Aha! I'll literally burn some.
Yeah, I used to work so I've been for a long time, so last Friday, terrified.
Yes.
I worked Saturday and that's just be like,
Slash your tires on your Jeep.
yeah.
Yeah. On your Jeep. And then your four-wheeler, and then the truck, and
Yeah.
your mom's car, and then
No, I'm not gonna go. I'm not with you. I'll just go like later.
have a mom's house.
What?
They're all doing
Like,
dogs.
people out
They don't run your dog off. Hey, you think you should get- But I'm gonna do it.
What? Yeah.
Damn it, stop! 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 Right now! Jack, I'm not like letting him Oh. What? Oh, Jack. Why? That works. Did I do it right?
Yeah, so you want to.
What's the top? So I can make it a negative 9 or a negative 9. Oh, you're too slow. Jack, you ready for basketball trials? Yeah. Wait, so what do you play? I'm breaking your mask. Jack, so then what? Jack. Well, we're all like, we laugh, so I just got blown up by 45 years. We're having fun while he sits there. Like, why? Well, I remember, yeah, no, we gave it to you. What was that after the season? No, it was just, oh, really? Yeah, we had to go back and run. Oh, yeah, we gave it to
That's scary because
Gross deal.
that is also option.
Who's living in Doctor? Yeah, he's so good, though. Yeah, he's nice. Yeah. Looks like me. Please trust me. It's just This is literally all set. Eat that! We have to have one turn. Oh, wait. Oh, the college board is like. It's in my where the answer is.
On sprinkles and
Right here.
and she called me. She's the nice girl from Blonde.
So, what I'm saying, like,
You guys thought it was
what'd you do after this?
What? Zach, what? I mean, this is dumb because I can literally take one out.
Also, wait.
Check. Take the derivative of this. I did that. Hello. No. That's the problem too. Then you made me think of it because that's harder. So Zach, we do it like that.
This set of friends. That's it. Wait. That's not
She got multiplied. Very good. It doesn't matter anymore. You just gotta
Yeah.
take the battery off. Yeah, then times. Stop worrying about the battery. Try to leave it like this. Oh, actually, I like this. I got you right here. It says that.
This
I got you. Yeah, the order needs to come. Order needs to come. I'm kind of stuck there too. Check. See it blood. It's the same. Sorry, I don't want to.
You should have been
My back on it. No, I just put it in my eye. Right. He just wants jet ski. I don't know why. It's snowing.
honestly, wait, I was
Leaving for college. It does love saying. We gotta go and have it. So this jet ski is separate. You guys are looking at me looking so I want. So it's still valid. So now it's rewritten as 7. Sorry, what's your mind? Like 5 minutes. Oh,
Alright, sorry about that. Thank you for your patience.
I think we threw it on.
You guys got this done? I don't even need to do it anymore?
I don't know if I can finish it though. Or I mean, I don't know if I have to go any further.
I have to do my job still?
Yeah.
Okay. You can't have, well, you can't have two terms. There's going to be a plus sign in it, but you can't have two terms. So,
The only time it wouldn't be a case is like a fraction, all fraction.
no, so it's like something like this. That's one term. Even though there's a plus sign in it,
Oh.
it's a multiplication, it's a product. It's one thing. So, yeah, you're going to have plus signs, but it's just going to be one term. Is that it?
So all that matters is that the plus signs are within parentheses, right? Like
Yeah.
so
That's a good way to say it, yeah.
can't you just take a 1 out of everything and then fix it? Hey,
No, that's, I mean, I'm trying to be pretty friendly with the simplified. I think you're pushing a little too far.
okay.
I have a question about this.
Can I do the freaking problem?
Multiply parentheses together. Like parentheses is different. Multiply them.
You can, like, take them both out, yeah. That's what we're going to do. So here, let me do it. I feel like doing the problem might help answer some of these questions. Just a thought. Just throwing it out there. So, the second thing, right, times the derivative of the first thing, but for the derivative of the first thing, I need chain. Yes? So 3, leave the inside alone, reduce the power by 1, multiply by the derivative of the inside. We're too big. I gotta do that again. Second thing times the derivative of the first thing times the derivative of the inside. Okay, then the first thing times the derivative of the second thing. So bring down the 5, leave the inside alone, reduce the power by 1, multiply by the derivative of the inside. Agree on that stuff? You good there?
Yes.
Okay. So then what you're going to have, and this works out, because the way derivatives work, you're reducing the power by 1. So you're going to have like a chunk of things here, and then one less of those chunks over here. So what you want to do is take out, I want to take out 4. We've got 5 of them there and 4 of them there. I can factor out 4 of them. So I'm going to have 4 of those. Leave some space to like show what's going on if I need to. So I'm going to have negative x to the 5th plus 2 to the 4th. How many negative 3x plus 2's can I take out? Got 2 there and 3 there, so I can take 2 out. So negative 3x plus 2, I can take 2 out. So what you just did was divide both of these terms by negative 5x plus 2 to the 4th and negative 3x plus 2 squared. So if I do that to this term, yeah,
Why didn't you take 4 of -5x?
why can I take 4 of these? I can take the bigger or the smaller of the 2 amounts. I've got 5 there and 4 there. So if I take 4 from this, there's still 1 left. If I take 4 from there, they cancel.
Oh.
Does that answer your question, Matthew?
Yes.
Okay. So, if I take it out, you're essentially dividing both terms by that. So, isn't there going to be 1 of these left? So negative x to the 5th plus 2. How many of the negative 3x plus 2's will be left? Yeah. Don't they both cancel?
Oh. Oh wait, that's
Right?
the other one.
I'm on the left-hand side still.
Yeah.
And then I've got the 3 and the negative 3, which I'm fine if you leave this right here like it is. Back your answer sheet won't, but you are allowed to, yeah.
So I can make it -9.
Absolutely.
Okay.
So then over here, same thing. I just divided by negative x to the 5th plus 2 to the 4th, negative 3x plus 2 squared. So, how many negative 3x plus 2's do I have left? 1, right? Because I have 2 on the bottom that'll cancel out, and there's 1 remaining. Then I've got this 5. How many negative x to the 5th plus 2's are left? None. They're gone. They killed each other. And then the negative 5x to the 4th is there. So, I'm fine with that answer right there. So, good news is I'm fine with that answer, so is the AP test. Bad news is on a multiple choice, you have to keep going and simplify this. And the bad news is to see if your answer matches the back of that, you have to keep going, which I'm totally fine with because it's worth practicing that, making sure. Why is that? Would you like to discuss your anger? So, I mean, that's a fair question, but why do you have that question about this one, but not any other question we've done this year? Like, what's special about this that angers you? What, 2 steps?
You're making me factor out entire parentheses.
Why am I doing that?
I know why you're doing it, but like.
Well,
Make us mad.
it's for that purpose. So,
I do remember that. I am perfectly. I know why you're doing it. I just don't like it. It's a lot.
I don't know what to tell you.
I don't know enough.
I mean, in past years, I've made you go on and do this too, so I could make you more angry. I feel like I'm being pretty friendly. Can we move on for your conflict session now? There's I think, a math question back here. Kenzie.
Are you gonna have to make us like do all of this and then find the coordinates of something?
I could ask you to do this,
Don't give them ideas.
and then no, it's not that. It's not as bad as you think. Like if you say don't do what you're just asking,
Yeah, just
Okay,
don't
fine.
do it.
I could say like find where the tangents are horizontal, but it's not that bad. You set that equal to 0, you set that equal to 0, and you'd simplify that and set that equal to 0. Don't you think the ones Thursday and Friday were harder?
Yeah.
I think they were a lot harder.
Is that the question one?
Yeah,
Yeah.
for sure. Calculus isn't that bad.
Yeah.
Wait, I don't want to. I think our time is better spent doing more problems rather than like whining about it. All right, let me do one more before. What time is that? Until 11:02. 11:04. 2. Fine. All right. Second thing times the derivative of the first thing. So this is the chain rule for the derivative of this guy. With me? I don't know if you guys are like watching or doing it on your own or some of both. I'm trying to figure out like I don't have a ton of time to wait before I go through it because the clock's ticking. Just go. We're good. And then the first thing times the derivative of the second thing. So again, that's chain rule. By far the biggest mistake I see in these is you'll forget this 4x or this 20x to the 4. The chain rule part of the product rule. So now, I look for my chunks. How many 4x to the 5th minus 3's can I take out? Just 1. And how many 2x squared minus 1's can I take out? 2. after I do that, does that make sense? Like why you can take 1 and 2? Yes, but you don't have to. All I need to see is the big chunks.
What does that mean?
The stuff with pow, like the stuff in parentheses. She was saying can I take out a 4x?
Well, what if I put the 20 next to it? Or
The stuff that has the same
13.
things as were in the original parentheses. How about that? I don't know if you're asking a real question. Or
no,
just
I
being
was a
like,
kid.
okay, sorry. So like you see how there's that and that.
It's there.
That's what I'm looking for. The chunks.
So like the big term.
Yes.
Not the one with the standing.
Yes. So if I do that, what's left here is 1 of the 4x to the 5th minus 3's. This 3 and the 4x. Because that one cancels. And what's left over here would be 2x squared minus 1. 2, this goes away. And 20x to the 4th. And in my mind, you're done. You factored out the chunks, you did what you're supposed to do. You want to check your answer with what they have, you're going to have to go through and do this. I'm not going to make you do that out of the gate. Yeah.
I think it's very good. Like, go through each of our tests and like, what if somebody went further and simplified? Is that wrong, or do you want like?
No, as long as you did it correctly, you would still get points. So yeah, I'll go. Like when I make my answer key, I'll put this answer and like 2 or 3 other ones I think people might come up with. And yeah, you don't have to like think like me. You don't want to think like me. Just figure out what you did.